Hi and welcome to another presentation of Tech for Everyone, free training in tech provided by eTrain. Today's presentation is all about network cabling. We're going to see if we can find out what's going on in terms of twisted pair, coaxial and fiber optic cables. We're also going to see if we can identify the connectors used on these cables for our networks. Well, most networks today, especially in business, use cables to connect their machines. Wired networks are a lot more secure. Despite the popularity of wireless networks, most businesses tend to stick to wired ones. Now, the wire in use is copper, insulated and twisted for some reason. We're going to see if we can find out why. But you also need to be aware that there are new technologies, especially the fiber optic technologies that exist out there, that are becoming more and more popular. Well, our first type of cable is the unshielded twisted pair. You can see a nice photograph of that type of cable right there. And you can see that it consists of 4 pairs of copper wires. Each wire is insulated from the other and is twisted. Now there's a reason for the twist. It's referred to as crosstalk. You're trying to reduce crosstalk, and all crosstalk is interference between the wires themselves. I mean, if we didn't twist them, there would be interference with the signal, and that wouldn't be very good. It's also put there to try and reduce EMI, electromagnetic interference. Any wire carrying a current has a small magnetic field around it, and that in turn can affect the signal that it's carrying. So we're trying to minimize that as much as possible by putting the twist on the cable. If you want to reduce EMI even more, you could use shielded twisted pair. As you can see there, it increases the protection against EMI. How does it do that? Well, you can see from the photograph that each pair of wires has a foil shield around it, thus minimizing EMI and crosstalk and all that sort of stuff. One of the drawbacks is because of the foil shield, it's less flexible and it's heavier. And as a result, it's also more expensive. But if you can afford it, then STP is definitely the way to go. When it comes to cable bandwidth, that's the capacity of the cable, the amount of bits that it can carry, there are certain standards that are followed, coming from the Commercial Building Telecommunications Cabling Standards, or CAT for short. Now, for the CompTIA A+, you can see that it ranges from 3 to 6. 3 being the smallest, a capacity of 10 megabits per second, and 6 in excess of 1 gig per second. Now, you'll notice that they have specific standard names. Again, for the CompTIA A+, it's important that you remember those. It's also important that you remember that when we're talking about twisted pair cable lengths, there is a standard, so to speak. Try and remember that twisted pair cabling can be no longer than 100 meters, and that patch cords, a length of cable linking a PC to a wall point, should be no longer than about 5 meters. Anything above that, and then we're going to start to have issues with the quality of the signal. Now, if you've wondered, well, how do we connect this cable to our PC or other device? We've got to have specific connectors. And for twisted pair cabling, the standard is the registered jack or RJ45 connector. As you can see there, it's the one at the top, nice and big to accommodate the 8 wires. It is unfortunately sometimes confused with the RJ11. It's smaller, and that one is used on 2-pair cables, and 2-pair cables are only used really for telephone signals. Now, the problem is that the RJ11 connector is sometimes put in the RJ45 port because it's smaller, and that can cause a lot of confusion for some people, so you need to be very careful indeed. Another type of copper-based technology is coaxial. You probably see this when you are connecting up your satellite TV, but it's also used in data transmission, which is basically what satellite TV is. But let's take a look at it now. What we've got is a central core, you can see there on this diagram, surrounded by an insulator, it in turn surrounded by a metallic shield, and the whole thing wrapped in plastic. And that's why I've summarized it with the bullet points that you can see there. A single conductor surrounded by an insulator, a metallic shield wrapped around the insulator to reduce EMI again, and the whole thing wrapped in a plastic jacket. Now, one of the problems with coaxial cable, as you'll see, has to do with the bandwidth. And what we'll talk about is the relative bandwidth of the two types. There are two types. There is thicknet, or 10 base 5, and there is thinnet, or 10 base 2. In both cases, the bandwidth is relatively low, so it's not necessarily as popular as it used to be. If we're going to be connecting coaxial cable to a device, then we tend to use the BNC, or the British Naval Connector. It's not the only means of connecting coaxial cable, but it's certainly one of the more popular methods. It uses a twist and lock bayonet mechanism, which you can't quite see in the photograph there, to hold that cable in place. Fiber optics are popular because even though they're a little more expensive, they are relatively good in terms of bandwidth. So let's take a quick look at those. Now, the problem with copper cable that I've been telling you about is the fact that it is subject to interference. Now, light signals don't have that problem. They're not affected by EMI and therefore can travel greater distances before the signal quality degrades. In terms of structure, it's quite similar to coaxial cable. You can see you've got a central core, and that is where you will find the flexible glass-like substance. That in turn is surrounded by plastic cladding. The cladding also ensures that the light travels along the core and is not lost to the sides. In a standard fiber optic cable, you're going to have some fibers that are responsible for upstream and other fibers responsible for downstream, although that can vary sometimes. But the whole thing is going to be contained in a protective jacket. There are two main types of fiber optic cable. There is single mode, where you've got a small core and the cable can run for many kilometers, but is expensive. And you've got the multi-mode, a larger core, it uses LEDs, light-emitting diodes, the cable run is up to 500 meters, still pretty long, and is relatively cheap. How are we going to connect this fiber optic cable up? Well, we've got several choices. They are quite varied, and you can see some of them in the photograph there. In terms of the CommTier A+, the ones you need to focus on are the ST, or straight tip, the FC, or the ferrule connector, the SC, or the subscriber connector, and the MTRJ, the mechanical transfer registered jack. So, in summary, UTP, 4 pairs of wires, cheap, bandwidth is based on the category used. We can go STP, which also uses 4 pairs of wires. It's expensive and it's less prone to EMI. Both types use an RJ45 connector. Coaxial, very low bandwidth, and uses a BNC connector, that British Naval Connector. And of course, you've got fiber optic, which is expensive, long cable runs, but absolutely no EMI. You've got various connectors that you can use on it: ST, FC, SC, and MTRJ. I want to thank you for listening to this presentation from Tech for Everyone, and I hope to see you next time.